All right, so let's look at this one. I don't think this one was on. I don't think this is from a previous exam, but it's one that I wanted to look at. So again, we have this same series, and by definition, the sum of this series is equal to the limit of the partial sums. That's just by definition. This isn't a theorem or anything, but by definition, the sum of this series is equal to the limit of the partial sums. And for this problem, we're given what the partial sums are. It's similar to the previous problem. It's 7n squared plus 5 over 5n plus 2. Okay, and again, this is a sort of, you can either do L'Hopital's rule here or something else. I'm going to divide the top and bottom by n squared because that's what the highest power of n here is. Some of you, I'm assuming, many of you, already see what's going to happen here. If I divide the numerator by n, if I divide the numerator by n squared, I'm going to get 7 plus 5 over n squared. And then in the denominator, I'm going to get 5 over n plus 2 over n squared. And so what's happening in the numerator, so the numerator is just going to 7. This is going to 0, that's 7. In the denominator, this is going to 0, this is going to 0. So this is going to, 7 over 0. In other words, as n gets bigger and bigger and bigger, this grows unboundedly, and so this is equal to positive infinity. Okay, so what this tells us is that the limit of partial, or the sequence of partial sums, does not converge, it diverges to infinity, and therefore this series does not exist. Sorry, I didn't mean to do that. Since the limit as n goes to infinity of Sn is equal to positive infinity, the series diverges. Okay, and that is it.